Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. So today we're going to start Unit 6, Lesson 5. Our main topic is solving radical equations. So we're going to have some equations with radicals in them, and we have to figure out how to solve for our variable. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. Today's objective is I will solve radical equations and check for extraneous solutions. Mastery will be demonstrated by scoring at least an 80% on the extra practice. So once again, we are going to be running into some extraneous solutions, which has happened throughout this school year. So we're no stranger to them, but we always have to check our answers and make sure that we don't have an extraneous solution. So just a reminder on what that is. Remember, it's a solution that you get when you solve the problem, but it doesn't actually make the equation true. Get when solving the problem, but doesn't make the equation true. So we're just jotting that definition down just to remind us what an extraneous solution is. So let's talk about some radical equations. In example 1, part A, 2 times the square root of x is equal to 10. So the first thing we always want to do when we solve a radical equation is we want to isolate the radical. And what that just means is you want to get the radical by itself. So 2 root x equals 10. There is a 2 with this radical on the left-hand side there. We want to get rid of that 2. So what does it mean to have a 2 out in front of the root x? It means multiplication. Well, how do I cancel multiplication? I divide. So 2 divided by 2 is 1. 1 times root x is root x. 10 divided by 2 is 5. Now we need to figure out how to get the x out from under that radical. So what is a way, I'm going to think to myself, what is a way to cancel a square root? Well, if the opposite of square rooting is squaring something, or if the opposite of squaring something is square rooting, then what happens if I just take this radical and I square it? So I'm going to show you what mathematically happens. I'm going to write out my work. The square root of x squared is the square root of x times the square root of x. 5 squared is 25. Then we take the root x times root x is root x times x, or the square root of x squared. I've got a group of 2 x's under my radical. I'm going to bring that out. I have an x out in front of the radical now. There's nothing left in the radical. I'm done with it. So I'm left with x equals 25. So what happens is when you square root a square, the square and the square root cancel each other. And you're left with simply what was under the radical, which is x. And so we get x is equal to 25. Now we need to make sure that this actually works. There's some values or restrictions on our answer. So if I look back at the square root of x, when I take the square root of a number, in order to get a real number for my final answer, I only take the square root of a positive number. Remember, when we take the square root of a negative, we get imaginary solutions. So that means that whatever x is has to be greater than or equal to 0 because it has to be positive. Well, our final answer is x equals 25, and 25 is greater than or equal to 0. So that checks out. But I'm going to plug it back in just to double check. So 2 times the square root of 25 is equal to 10. The square root of 25 is 5. 2 times 5 is 10, which is a true statement. All right, why don't you go ahead and try the next one on your own. So solve for x, and 3 times the square root of x equals 9. And see what you get. So you should have gotten x equals 9, divide both sides by 3, square both sides, x equals 9. Now look back underneath your radical. So whatever x is, whatever's under the radical has to be positive, which means that x has to be greater than or equal to 0. 0 is the least number we can put under the radical and get a real number back. So x has to be greater than or equal to 0. Our final answer is greater than 0. So that's a good sign. And then if I plug it in back in just to double check and make sure our answer works, 3 times the square root of 9 equals 9. The square root of 9 is 3, and 3 times 3 is in fact 9. So that checks out. If it didn't work, or if we got a solution that won't work under the radical, then we would say that it's extraneous. But so far, our solutions are working. All right, the square root of x over 4 equals 7. So again, we want to isolate the radical first thing. How do I cancel the square root of the square root of x over 4? I need to isolate this radical. Here's a hint. What's the opposite of division? Do that to both sides. Go ahead and give this a shot on your own. All right, so as you can see, I multiplied both sides by 4 because the opposite of dividing by 4 is multiplying by 4. 7 times 4 is 28. To get rid of my radical in the square root of x, I squared both sides, and I got x is equal to 784. Now I considered my restrictions. So x has to be positive because it's under a radical. So x has to be greater than or equal to 0 because all positive numbers are greater than or equal to 0. 784, the answer we got, fits that scenario or rule. Then I plugged it back in just to double check. The square root of 784 is 28, and 28 divided by 4 is 7. So that checks out. All right, let's do some more complicated problems. So we've got in example 2 here, we're still solving these radical equations, but there's just a few more steps for us, of course, just to keep it fun, you know? We don't want things to be too boring. Now, for part A, we have 3 plus the square root of 2x minus 3 equals 8. So this time we've got 2x minus 3 under the radical. So for our restrictions, we're going to consider that 2x minus 3, that whole thing has to be greater than or equal to 0. So for our x values then, we're going to add 3, we're going to add 3. 2x is greater than or equal to 0. Just kidding, 0 plus 3 is 3. Divide by 2. So our x values have to be greater than or equal to 3 halves. And again, that 2x minus 3 is just that piece under that radical. Whatever our solutions are, they have to be greater than or equal to 3 halves in order to work for this radical. Anything less than that will give us a negative under the radical. This time, if you use 0, so like let's say we end up with 0, the square root of 2 times 0 minus 3, we're going to get 2 times 0 minus 3 is negative 3. Well, 3 plus this, what's going to end up being an imaginary number, because we have a negative under the radical, that imaginary number isn't going to add to 3 and get 8. So that's not going to work. So this time, all of our numbers have to be greater than or equal to 3 halves. Our answers, sorry. So let's see what we get. Well, once again, we still want to follow the same rule from example 1. We always isolate the radical is our first step. So we want to get the square root of x minus 3 by itself on the left-hand side. Well, what's keeping the square root of 2x minus 3 from being alone? This 3. Well, that 3 is positive. So to move it to the other side, I'm going to subtract it. So 3 minus 3 cancels. Now I'm left with positive, or just the radical, 2x minus 3. The square root of 2x minus 3 equals 8 minus 3 is 5. Well, now we have a square root equal to something. So once again, even though, there's something underneath the radical, we're going to square both sides, because squaring the radical cancels it. So we're going to have 2x minus 3 is equal to 25. Now keep solving from there. Add 3 to both sides. So 2x is equal to 28. Divide both sides by 2. X is equal to 14. Now, before we actually, circle that and say it's our final answer, we need to check for our extraneous solution. Well, is 14 greater than or equal to 3/2? Yes, it is. So it should work, like it's allowed in the solution set. But let's plug it into the equation just to make sure. So 3 plus the square root of 2 times 14 minus 3 is equal to 8. 3 plus the square root, 2 times 14 is 28, minus 3 is 25. 3 plus the square root of 25 is 5, equals 8. 3 plus 5 is 8. So our solution of x equals 14 does work. We're going to circle it and leave it as our final answer. All right, let's see if you're ready to do one on your own. The square root of 4x plus 1 minus 5 equals 0. Remember, isolate that radical first, double check what you're allowed to have for your solution set, and check for your extraneous solution. Go ahead and give this a shot, and we'll talk about it on the other side. All right, so the first thing I did was added 5 to both sides because that negative 5 is outside of the radical. I need to isolate the radical and moved it to the other side by adding it. Then I squared both sides because squaring cancels the square root. That left me with 4x plus 1 is equal to 25. I subtracted 1 to both sides. I divided by 4. I got x equals 6. Now let's double check that x equals 6 is allowed as a solution. So remember, what's under the radical, 4x plus 1, has to be positive. So we want whatever that is to be greater than or equal to 0. Subtract 1 from both sides. So for this problem, for what's under the radical to stay positive, x just needs to be greater than or equal to negative 1/4. So if I consider my solutions, 6 is 6 greater than or equal to negative 1/4? Yes, it is. So for this problem, we're actually allowed to plug in some negative numbers because as long as they're greater than or equal to negative 1/4, like we could plug in negative 1/8 if we wanted to, we could plug in negative 1/16, any number that's smaller than or bigger than, sorry, negative 1/4, including negative 1/4 because it's equal to, we could plug into this radical and we'd still end up with a positive number under the radical. So that's kind of cool. So 6 is greater than or equal to negative 1/4, so it's allowed according to that restriction. Now let's look at the original problem though. 4 times 6 plus 1 minus 5 equals 0. 4 times 6 is 24. 24 plus 1 is 25. The square root of 25 is 5. Subtract 5 and you do in fact get 0. So x equals 6 is allowed. We don't have an extraneous solution. All right, now let's do some, a more complicated example. So the square root of x plus 7 minus 5 is equal to x. So once again, we want to make sure that this radical is isolated. We're going to add this 5 to both sides. But this time, on that right side, while the radical is by itself now we have x plus 5. We have a binomial on the right-hand side. So what happens is, to cancel the square root, we're still going to square both sides. That doesn't change. When I square the square root, it cancels. I'm left with x plus 7. But now I have x plus 5 squared, which really means x plus 5 times x plus 5. We need to multiply that out. X times x would be x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Now we have a degree 2 polynomial. And for that degree 2 polynomial, we need to make sure it's equal to 0 before we can finish solving it. So we are going to subtract 7 to both sides. We're going to subtract x to both sides. We're going to get these cancel, so 0 equals x squared. 5x plus 5x would be 10x, minus x is 9x. 25 minus 7 is 18. So remember, a degree 2 polynomial function. To be able to solve this, We can factor it, use the quadratic formula, solve by completing the square, whatever floats your boat. I'm going to go ahead and factor this thing because I recognize that factors of 18 that add or subtract to be 9 are 3 and 6. So x plus 3 times x plus 6 is what x squared plus 9x plus 18 factors to. My two solutions are going to be, we said each factor equal to 0. And we get -3 and -6. So here's the thing. We've got two solutions that we need to check. So if you look back at your radical, the only solutions we want to consider are x plus 7 is greater than or equal to 0. X has to be greater than or equal to -7. Well, -3 is greater than or equal to -7, and so is -6. So according to this rule, both of these check out. But we still need to plug them back into the radical, into the actual equation, and just double check that it all works. So let's do that. We're going to check x equals -3 first. So the square root of -3 plus 7 minus 5 is equal to -3. So as you can see, I just took -3 and plugged it in for x from that initial equation. Both of those x's got replaced by -3. So is the square root of 4 minus 5 equal to -3? The square root of 4 is 2, and 2 minus 5 is in fact -3. So that solution works. X equals -3 is an answer. Now let's check -6. So the square root of -6 plus 7 minus 5 is equal to -6. So check this out. The square root of -6 plus 7 is the square root of 1. But hey, the square root of 1 is +1, and 1 minus 5 is not -6. That does not work. So that means x equals -6 is extraneous. So even though according to x is greater than or equal to -7, -6 would have been allowed as an answer, it still ended up not working and making the original equation true, which happens, which means that x equals -6 is extraneous and your only solution is x equals -3. All right, why don't you go ahead and try part D all on your own. You've got to follow the same steps, move that 3 to the other side, square both sides. You are probably going to end up doing a little bit of factoring to find your final answer, or you can use the quadratic formula, whatever floats your boat. Give it a shot though. Check for extraneous solutions and see what you get. All right, so hopefully our answers match up. I ended up with x equals 10 and x equals 1. As you can see, I subtracted 3 to both sides, I squared both sides, and then I made this thing equal to 0. I factored what I got on the right side to x minus 10 times x minus 1. Those two factors give me x equals 10 and x equals 1. So we need to check for our extraneous solution. So before we start circling our answers, and I know for my domain restrictions that 5x minus 1 has to be greater than or equal to 0. And I'm going to add 1 to both sides. And I get 5x is greater than or equal to 1. I divide by 5. And right off the bat, I see that 10 is greater than or equal to 1/5. So is 1. So even with those domain restrictions, these two answers are allowed, but we still need to check them to see if they're extraneous. So when I do that, I'm going to check x equals 10 first. The square root of 5 times 10 minus 1 plus 3 is equal to 10. So the square root of 50 minus 1 is 49. The square root of 49 is 7. Adding 10. Adding 3, we get 10. So that checks out. Then we need to check 1. So we're going to have the square root of 5 times 1 minus 1 plus 3 is equal to 1. So the square root of, I got 1, right? Yeah. 5 times 1 is 5, minus 1 is 4. So we get 4 plus 3. The square root of 4 is 2. And 2 plus 3 is not 1. So x equals 1 is extraneous. Remember to label it as extraneous. And the only answer that works is x equals 10. All right, so as we continue our solving our radical equations, square roots aren't the only radical on this planet, right? So we need to be able to solve equations that have third roots, fourth roots, fifth roots, sixth roots, 100th roots, whatever n is, that index n. So let me walk you through how to solve a problem like this. So 3 times the cubed root of x plus 1 squared is equal to 12. So what we do is, again, always isolate the radical. Always isolate the radical. So I'm going to divide both sides by 3. And I get the cubed root of x plus 1 squared is equal to 4. So from there, what do I do? Well, how did we cancel the square root? When we did our work up here, how did we cancel our square roots? We squared it, right? So how am I going to cancel a cubed root? I'm going to cube it. All right, so the cubed root gets canceled by the cubed. We're left with what is under the radical. And so we get x plus 1 squared is equal to 4 cubed, and 4 times 4 times 4 is 64. Now from here, we have a couple options. One is we can go ahead and square this thing, or the other option is we can cancel the square by square rooting both sides. And since 64 is a perfect square, 64 has a square root, let's go ahead and do that. But remember, when you square root both sides of an equation, you have 2 solutions, the positive and the negative. So the square root of 64 is 8. From there, we're going to subtract 1. So x is equal to negative 1 plus or minus 8. We're going to go ahead and simplify both of those. X is equal to negative 1 plus 8. X is equal to negative 1 minus 8. X is equal to 7. X is equal to negative 9. But we always have to check for extraneous solutions. So we're going to go back and plug these guys in. We're going to take 3 times the cubed root of, the first one I'm going to check is 7. 7 plus 1 squared is equal to 12. 3 times the cubed root of 7 plus 1 is 8. 8 squared is 64. And isn't, what, 4 times 4 times 4, 64? Yeah. So the cubed root of 64 is 4. 3 times 4 is in fact 12. So x equals 7 works. X equals negative 9. The cubed root of 3 times the cubed root of, let's see, negative 9 plus 1 squared is equal to 12. So negative 9 plus 1 is negative 8. Negative 8 squared is 64. The cubed root of 64 is 4. 3 times 4 is 12. So both of these solutions work. So our answer is x equals 7 and negative 9. And there we go. All right, now why don't you go ahead and try 3 times the 5th root of x plus 1 cubed, all plus 1 equals 25. I'm going to walk you through this step by step. So the first thing I want you to do is to isolate the radical. Go ahead and do that on your own. So hopefully you subtracted 1 to both sides. and then divided by 3. Then how are we going to cancel the radical? So how do I cancel the 5th root? I take it to the 5th power. So x plus 1 cubed is equal to 8 to the 5th. What's 8 to the 5th? 8 times 8 times 8 times 8 times 8. Okay. Is 32,768. So x plus 1 cubed is equal to that big number. Then we are going to cancel the cubed. So how are you going to cancel the cube? You're going to take the cubed root. So the cubed root cancels the cube. We're left with what was under the radical. And now we need to find the cubed root of 32,768. So I figured out that the cubed root of 32,768 is 5 2s. And 2 to the 5th, or 2 times 2 times 2 times 2 times 2, is 32. And if you double check that, 32 times itself 3 times is in fact 32,768. Then we're going to subtract 1 to both sides, and we get x is equal to 31. But before I circled that, I should have checked it. Okay, so let's do this. 3 times the 5th root of 30, what do we get? 31 plus 1 cubed plus 1 is equal to 25. So 3 times the 5th root of 32 cubed plus 1 is equal to 25. Okay, so instead of having to like write this all out again, I already know that 8 to the 5th is 32,768, and 32 cubed is the same thing, right? So I know that 32,768 is the same thing as 8 to the 5th. And the dogs are about to go crazy in a second. So that gives me 5 8s under the radical. I'm going to bring that out. I get 3 times 8 plus 1 is 25. 24 plus 1 is in fact 25. So it works. No extraneous solution here. All right. Now let's talk about example 4. All right. Example 4. All right, so in example 4, we're still solving a radical equation, but this time we have a radical equals a radical. So like the square root of 3x is equal to the square root of 2x plus 1. So in order to solve these, since the radicals are already isolated, each one is on its own side, what I recommend that you do is you just take a square and square both sides. Look at this magical thing that's about to happen. The square cancels the square root. The square cancels that square root. And we're left with 3x is equal to 2x plus 1. Subtract 2x to both sides. You get x is equal to 1. Before we circle it as our final answer, we still have to check for an extraneous solution. Is the square root of 3 times 1 equal to the square root of 2 times 1 plus 1? 3 times 1 is 3. 2 times 1 plus 1 is 3. The square root of 3 is equal to itself. That is our final answer. All right, for part B, I actually want you to change the equation. I want you to do the square root of 3x is equal to the square root of 4x minus 1. Go ahead and give this problem a shot on your own. All right, so you should have squared both sides. The square cancels the square root. We're left with 3x is equal to 4x minus 1. Subtract 4x. You get negative x is equal to negative 1. Divide both sides by negative 1. X is equal to positive 1. And I forgot, we need to double check our answer. The square root of 3 times 1 is equal to the square root of 4 times 1 minus 1. Square root of 3 is equal to 4 minus 1 would be 3, the square root of 3. And again, we're left with a true statement. For part C, I want you to again change the equation. We're going to do the square root of 11 minus x minus the square root of x minus 7 equals 0. So what we want to do here is we actually want to isolate both radicals. So only one radical is on each side of the equation. It's just going to make our lives easier. So we're going to add the negative radical to both sides. And we end up with the square root of 11 minus x is equal to 0 plus the square root of x minus 7 is just the square root of x minus 7. From there, we're going to do the same thing we did before. How do we cancel a square root? We square both sides. Square rooting cancels squares, and vice versa. So 11 minus x is equal to x minus 7. Let's add x to both sides and add 7 to both sides. We're going to get 18 is equal to 2x. Divide both sides by 2, and we get x is equal to 9. Now, of course, we have to double check our answers. So when we double check our answer, we're going to plug 9 back in for x. We get the square root of 11 minus 9 minus the square root of 9 minus 7 equals 0. We get the square root of 2 minus the square root of 2. And anything minus itself is 0. So 0 is equal to 0. This final answer works. Now I want you to try part D on your own. So you're going to take the square root of x over 10 minus the square root of 3x minus 58 equals 0. Go ahead and solve for x following the same steps we did in part C. Press pause and then press play when you're ready to check your work. So hopefully you added the radical 3x minus the square root of 3x minus 58 to both sides. Then you squared both sides. And then to get rid of the x over 10, I multiplied both sides of my equation by 10. And that just canceled the x divided by 10. I subtracted 30x to both sides, divided by negative 29, and I got x equals 20. I'm going to leave it up to you to go back and check and make sure that we don't have an extraneous solution. And if we do have an extraneous solution, make sure you tell me about it when we go over our extra practice. So go ahead and get started on your extra practice and let me know when you're done.